Good noon, good morning, good afternoon, depending on what time zone you're in. If I could call this gathering to order. My name is David Hart. I'm a senior fellow at ITIF, where I head the Clean Energy Innovation team. ITIF is a think tank that is a nonprofit, nonpartisan organization that produces research and analysis to advance policy ideas, and as our slogan says, policy ideas for the innovation economy. My partner on the Clean Energy Innovation team is Colin Cunliffe. Saw him a minute ago. Colin is here for those of you who are interested in talking to us about our work. And it's my pleasure to moderate today's panel on the carbon tax and induced innovation. The carbon tax is often conceptualized as all pain. That is, we're going to force polluters to pay for the damage that they're causing. But there's a little understood aspect of that, which is the stronger incentive that it provides for clean energy innovation. So there's a gain as well as pain. But this important effect is not very well understood, and our purpose here is to try to bring it to your attention. And I think the most important aspect of it is not so much the static impact of the incentive, but the dynamic impact that is getting people thinking about clean energy innovation, and that can take on a life of its own that goes beyond the incentive. And I was very encouraged this weekend. There was a story in the Post by David Von Drele called Time for a Category 5 Storm of Innovation, obviously picking up on the weekend's events. So realization that there's this connection between the carbon tax and innovation is growing, and hopefully after today's session you guys will take that message back to your colleagues as well. We're going to feature the work of Joe Kennedy, who's a senior fellow at ITIF, his paper on carbon tax and induced innovation, so he'll present for about 20 to 30 minutes. And then we have a terrific panel to discuss it and also discuss the issue more broadly, and I'll introduce them in just a moment. And then after the panel gives their remarks, we'll be open for Q&A. So as we hear from the presenters, I hope you'll be thinking of questions and ideas that you want to share with them and to get their comments. And I do want to acknowledge the support for this paper from the Alliance for Market Solutions. I don't know if is Alex Flint here? But they provided the support to Joe to write the paper, so we really appreciate that. So let me introduce the panel very briefly, then I'll introduce Joe, and then I'll turn it over to him. So we have three excellent panelists. Alex Brill in the middle here is a resident fellow at the American Enterprise Institute, another Washington think tank. He's served on the Council of Economic Advisors at the White House, on the Ways and Means Committee up here, and apparently knows a lot about tax policy as a result. So we'll look forward to his remarks. Joe Makut is the Director of Climate Policy at the Niskanen Center. Previously was a AAAS fellow up here on Capitol Hill, has a background in atmospheric and environmental science, and is going to be our resident climate expert on the panel. And then Donald Marron. Donald is an Institute Fellow at the Urban Institute, probably well known to many of you in the audience already. Also served at the CEA and at the Congressional Budget Office, and was the director of the Urban Brookings Tax Policy Center. So obviously he may know something about tax policy as well. So hopefully there are a lot of tax policy geeks in the audience, because that's what we're doing here today. So Joe Kennedy is our kickoff speaker. As I said, he'll speak for about 20 to 30 minutes. He's a senior fellow at ITIF, where he focuses on economic policy. He was previously the chief economist at the Department of Commerce, also spent some time on the Hill, and he knows something about tax policy too. So Joe, the floor is yours.
Thank you. Hello, and thank you for joining us today. As he said, I'm Joe Kennedy, a senior fellow at ITIF and author of its recent report, How Induced Innovation Lowers the Cost of a Revenue-Neutral Carbon Tax. And we're printing more copies of that report as I speak. We're already in the second printing, so how awesome is that? But they should be ready as you go out. And so that'd be a good indication of how interesting my talk is. If everybody takes a copy, I must have been good. If nobody takes a copy, well, I'll get my resume polished. I want to also thank the Alliance for Market Solutions for providing generous funding for this report. AMS is an organization of conservative leaders trying to educate conservative policymakers on the benefits of a market-oriented solution to advancing clean energy and reducing carbon emissions. Ours is one of a series of reports that they've funded to develop the case for more rational policies in this area. In this presentation, I hope to convince you that additional innovation caused by a well-designed carbon tax can significantly reduce the economic cost of cutting emissions. Devoting the tax revenues to research can reduce these costs even further, to the point where a modest tax could actually have a positive impact on the economy while moving us toward cleaner energy. Next slide. In today's talk, I want to review the basic facts about a carbon tax. Second, I'll explain the theory behind induced innovation, and then summarize some of the many attempts to model its significance with regard to the energy sector and climate change specifically. Lastly, we'll look at the importance of how the government spends the extra revenue from a carbon tax and why tax reductions for work, research, and innovation are the best policy. Next. So if we want to reduce carbon emissions, we need to reduce both the demand and the supply. The demand side limits consumption of carbon-intensive energy and products. But we can also reduce the supply side by either using less dirty existing technology or by inventing better, cleaner technologies. Command and control regulations, on the other hand, require suppliers to use a certain technology or to reduce their emissions by a certain amount. These regulations tend to work best when the technology we want already exists, and all we need to do is increase the use of it. But in cases where we need to develop new technologies, such as climate change, it is usually more effective to put a price on carbon. Putting a price on carbon affects both the supply of emissions and the demand for them. There are two main ways to do this. A cap-and-trade program sets a ceiling on emissions and then either gives away the permits or sells them. The market and permits will then set a price for the carbon emissions. Under a carbon tax, the government sets the price and then lets the market determine the amount of emissions. A cap-and-trade program locks in the quantity of emissions, whereas a carbon tax locks in their price. Most economists favor a carbon tax because it more easily feeds into the existing market system. It also produces more revenue, since initial permits are often given away to incumbents in a cap-and-trade program. We shall see that the use of these revenues can play a big role in reducing the cost of emissions. A carbon tax also leaves room for upside surprises if technology advances faster than expected. Finally, a cap-and-trade program that is too ambitious may result in an unrealistic price, in which case it is likely to be withdrawn. A carbon tax responds to clear market failure. Because the Earth's atmosphere is common property, people do not consider the costs of greenhouse emissions when making decisions. Instead, they burn fossil fuels as long as the benefit to them of doing so outweighs the cost of the fuel, even if this still imposes costs on the broader society. A carbon tax corrects this market failure in two ways. First, by making emissions relatively more expensive, it encourages both producers and consumers to switch to cleaner methods and products using existing technologies. Second, and perhaps more importantly, it creates an incentive for companies to find cleaner technologies that both lower the amount and the cost of emissions. A tax also creates significant environmental co-benefits. A growing literature demonstrates the long-term costs of higher concentrations of small particulates in the air that we breathe. These costs are significant, but usually ignored when discussing a carbon tax. So why is induced innovation important, and how does it work? Induced innovation is important because most models of the socially optimal carbon tax, that which maximizes the social welfare, come up with an initial tax of roughly $10 to $20 per ton, rising to over $100 in a few decades. Beyond this, at any higher tax rates, the short-term economic cost of reducing emissions outweighs the long-term environmental benefits. Very few models justify a level of tax sufficient to keep the rise in global temperatures below 2 degrees Celsius. That's the level many environmentalists say is the maximum that can be sustained without severe costs to the planet. Yet there is very little support for either higher taxes or slower growth. Thus, in order to get larger reductions, we must hope for significant advancements in technology. Induced innovation claims that innovation responds directly to market prices. An increase in the relative price of an input, whether because of scarcity or government regulation, will cause companies to create more innovation directed at reducing the use of that particular input. And market prices will eventually result in this technology being commercialized and widely adopted, at least until something better comes along. These charts show how that happens. Let's imagine an equipment manufacturer trying to meet local demand. Chart 1 shows how companies decide what particular technology to use. Let's assume that the horizontal x-axis represents the cost of emissions, and the vertical y-axis represents the use of all other inputs that the manufacturer might use. The existing technologies are shown by the blue curve and allow the company to produce the same amount of a good using different combinations of inputs. The exact combination that it chooses is determined by the ratio of input prices shown in the orange line. In this particular case, the cost of production is minimized by producing at the tangent between the line and the curve. At any other point on the blue curve, the company will produce the same amount, but the costs will be higher. Chart 2 shows that if the relative prices change so that emissions now become more expensive, our manufacturer will find it cheaper to use a new production method. Given the new cost ratio, he will move from point A to point B. At this point, he is producing the same amount of machinery, but he's using less dirty fuel and more of the other inputs. This is the price effect. At this point, we're still assuming technology has not changed. In the next chart, chart 3 shows the effect of technological progress as society moves from the upper curve to the lower curve. Firms can now produce the same amount of machinery using fewer resources. In this particular case, new technology is neutral. It does not favor one input over the others. Finally, chart 4 shows the effect of induced technology, in which new technology is skewed toward fewer emissions. This effect, combined with the price effect in chart 2, gives the total response to a carbon tax. The theory of induced innovation assumes that increasing the relative price of carbon will increase innovation and steer future technology toward cleaner energy. Next slide. Economists have tried to model the size of this effect. Next. In the 1970s and 80s, the combined effect of stricter government regulations and higher prices from the oil crises acted as a natural experiment for a carbon tax. One study of patent data showed that companies did shift their research from traditional fuels to alternative fuels. A second study demonstrated a substantial relationship between energy prices on the one hand and improvements in energy efficiency and appliance on the other, with induced innovation accounting for 25 to 50% of the total increase in efficiency. A review of British companies subject to the EU's cap-and-trade system showed that these companies doubled their low-carbon patents and quadrupled their low-carbon research and development. So company research does respond to incentives. In the next slide, we start to see other economists who have attempted to combine models of climate change with models of innovation. One of the earliest attempts found that the effect of induced innovation was surprisingly small. However, this model assumed that any additional research on clean energy was completely offset by less research elsewhere. But this assumption is very unlikely to be true. Total spending on research is not fixed. Past spending on the race to the moon or the internet did not result in large research cuts to other parts of the economy. In some ways, these broad research efforts increase the value of more applied research by private companies. Studies with a more realistic assumption show much greater effects for induced innovation. One of these studies found that induced innovation could lower the cost of achieving a given amount of abatement by about 30%. Another of the leading modelers found that because new technology does not diffuse as rapidly as possible, the ideal policy always involves a tax to price carbon, and then subsidies to encourage even more research and faster adoption of clean energy. Next, the economist David Popp created a model focused only on fuel efficiency and not on the development of alternative fuels. It thus probably underestimated the total benefit of innovation. It still found, however, that induced innovation increased the social benefit from a carbon tax by 9.4%. But it's possible for carbon taxes to actually reduce innovation. If carbon taxes are too aggressive, so that they reduce the profits that companies need to invest in new technology, that can retard innovation, especially if the government is still subsidizing dirty technology. Next. These and other studies lead to a few broad conclusions. Most important is that induced innovation can significantly reduce the cost of achieving a certain level of emissions. By lowering the price of emissions, it can also make it more affordable for society to purchase a greater amount of reduction. Second, we need to worry not just about the invention of new technology, but also its innovation and diffusion throughout the market. As a result, the most effective policy combines a tax with some form of encouragement for companies to invest and adopt better technologies. Finally, the optimal timing for a tax depends upon assumptions about how quickly technology develops and spreads. Taxes that rise slowly give researchers time to develop better technologies. On the other hand, taxes that rise more quickly give companies an incentive to speed up adoption of the best current technologies, leading to efficiencies of scale. Next slide. So then how should we use the revenues from a carbon tax? CBO estimated that a carbon tax of $15 per metric ton, which rose by 2% annually, would generate almost $1 trillion over 10 years. The use of this revenue is very important to both spurring clean energy and reducing the cost of a tax to the economy. There are several ways to use the proceeds from a carbon tax. Some prominent conservatives would rebate the proceeds directly to all Americans as a regular dividend. This reduces the economic impact on consumers, especially those with lower incomes. Another possibility is to devote the revenues to deficit reduction, reducing the possibility of a future financial crisis. But neither of these options does much to increase economic growth, and therefore does little to lower the costs of imposing a tax. In contrast, devoting the revenues to business tax incentives for research would increase growth. Higher incomes would also reduce concerns about regressivity in the national debt. Next slide. Several studies have shown that corporate income taxes are much more damaging to economic growth than individual income taxes. CBO found that using the revenues from a carbon tax to reduce corporate taxes would cut the cost of emissions in half. A study by Ernst & Young estimated that a carbon tax that reduced corporate taxes and also reduced the amount of energy regulation would actually increase income by $3,000 per household. Another study showed that using a carbon tax to reduce corporate taxes could actually increase total welfare, offsetting the entire cost of a tax. This effect would be even more powerful if the proceeds are used not to reduce business taxes in general, but specifically to subsidize research and development. This would address a separate market failure. Because companies only capture 1/3 to 1/2 of the social benefits produced by their research, they do too little of it. Tax cuts that lower the after-tax cost of research can help address this. These subsidies reduce the negative effects of a corporate tax and will increase the incentive for clean research. Academic studies consistently show that private research produces large spillover effects that increase social welfare, and that policies like the Research and Development Tax Credit are effective in increasing private research. Polls show that public support for a carbon tax is also highest when at least some of the proceeds are used to fund clean energy research. But the benefits of a tax subsidy should go to other industries as well, because the market of failure affects them too. More research in all sectors will spur growth. Our report recommends several ways to support more research. Congress should increase the alternative simplified credit within the current R&D tax credit to 40%. It is currently 14%. Congress should also allow companies to apply the credit to collaborative research outside of the energy sector. Second, Congress could enact an innovation box similar to that of some of our competitors. This would give a much lower rate of perhaps 10 to 15% to the income derived from intellectual property that is developed and produced in the United States. Finally, Congress should return to the practice of allowing companies to expense their research costs. If these suggestions are adopted, a few studies suggest that the higher growth resulting from more research and investment may actually offset the costs of a modest carbon tax, producing environmental benefits at low or negative cost. We could create a win-win-win solution where we get stronger growth, cleaner technology, and fewer emissions, provided we set an appropriate tax rate and use the revenues to encourage innovation. Thank you, and I look forward to your questions after we hear from our panel.
Thank you, Joe. So economists, of course, have the saying, there's no such thing as a free lunch, which is true for us, but not for you. So there's still a few sandwiches over there. If you haven't grabbed one, now would be a good time to do that. And so now we'll hear from our panelists, and we're going to start with Alex.
Thank you. Thank you to ITIF for putting this event together, and Joe for putting together his paper and his remarks just now. I think that's a great research effort, and I'm glad that it is part of the bookshelf of conversations that we can reach to when thinking about climate policy, tax policy, and innovation policy. I want to just take a couple of minutes really to amplify 2 points that Joe made and add a couple of factoids about some of the dynamics that we've seen in the energy market in the last few years. So let me just jump right in. First, the broad concept here, the broad topic this morning is about innovation policy and the role of a carbon tax in that framework. And so I want to step back for a moment and think about the role of the federal government in innovation policy in general. And I think it's a reasonable question to ask if our objective should be the federal government is more engaged in promoting innovation policy or promoting innovation, or should our objectives be to get the government out of the way of innovation? That we'd be better off with less policies here. And as I think about this, and Joe talked about this towards the end of his remarks, I think it's important to recognize that left alone, there's a natural market failure that can occur with respect to the amount of R&D that we undertake in our economy. And that the way in which that arises is relatively straightforward. If someone invests time and money and effort and takes risk and invents something, often that invention is brought to market and quickly met with competitors, copycat products, other products that are either identical or similar in nature. And the market for that innovation is then shared among all of the manufacturers of that product or those class of products that are similar. So somebody comes up with the idea, and quickly that marketplace can be filled with other competitors making that same or something similar. And to the consumer, we often think of this as a great thing because we might get slight variations in that product to tailor to our own tastes or preferences, and that competition might help bring down the prices of those new products. So we might, as consumers, see this competitive dynamic as a positive, that one guy doesn't get to just do whatever he wants and hold the market hostage, but rather it's shared more broadly. But that view sort of starts to crumble when one recognizes that innovation might not occur in the first place if the inventor recognizes that risk, recognizes that they may put time and money on the table to come up with something, only to then find out that once they bring it to market, they're quickly outbid or underbid by others who are copycats to the marketplace. Now, obviously, to prevent this in general, we have a set of policies, and the first one that comes to mind is the fact that we have a patent system, and the patent system protects innovation and inventions this way. But the patent system doesn't protect all innovation, doesn't protect all new products, and sometimes, as a result, oftentimes, what we'll see is that inventors or researchers will underinvest in the R&D for a particular market or product out of recognition or out of fear that they will not be able to capture all the gains or all the rewards from that risk that they take. And Joe talked about that towards the end of his remarks. And I think that dynamic is important to recognize in our economy, really in any economy. And it leads me to conclude that the right answer with respect to innovation policy is that we want the federal government to be somewhat engaged in this issue and concerned about this, rather than to say we want to make sure that there's no role for innovation policy. So we need some sort of innovation policies to ensure or encourage that additional innovation that otherwise wouldn't occur actually does occur, so that we have more research, so we have more innovation, so we have more gains in productivity ultimately. And Joe talked about the R&D tax credit. That's after patents. That's the next one that certainly should come to mind for a lot of folks. I'm not a huge fan of that policy. It's a little bit better because it's permanent, and so at least there's some certainty around it. But its intent is good. Its intent is to help create this incentive or this encouragement for firms to do more R&D than they otherwise would, given the potential for a market failure and underinvestment. And so, how exactly to construct those innovation policies, are generally speaking, I think, is a hard question. It's a question that ITIF is expert in and one that they think a lot about. For me, it's a hard question. in general. But when we think about how to encourage that innovation with respect to energy markets or clean energy or energy conservation or innovation to reduce the amount of CO2 emissions, I think the question becomes much more straightforward. And that's where a solution like a carbon tax, I think, is a sound one and a logical one, because it internalizes, or it brings into the cost of a good that emits carbon, that social cost of that emission, of those emissions, thereby raising the price of those goods and thereby creating that opportunity for the inventor, for the investor, for the innovator to find ways. And there was references in the opening remarks about clean energy, and we often think about this as a battle between carbon-intensive energies and cleaner energies. I think it's also important to remember that the total amount of energy is also one of the variables that's up for debate here in terms of how the economy evolves. And so it's not just where we get our energy, but it's in fact how much energy we're going to use. That has a lot to do with energy efficiency and energy conservation. And that brings me really to my second point, which is that this market that we're talking about, this energy market, is, I think, very adaptive. And I think that's an important aspect to recognize, that innovation is occurring, that there's flexibility, that there is changes in the marketplace that we've seen in the past, and that a carbon tax can help promote going forward. And so the Energy Information Agency, part of the Department of Energy, keeps track of lots of good fun facts with respect to energy and how we use it and what type of energy we use. They announced last week that the amount of energy-related CO2 emissions in the United States last year, 2017, fell relative to 2016, fell almost 1%, 0.9% lower. So there's fewer CO2 emissions from that sector, from the energy sector in the United States. And the primary driver, according to EIA, is a decline in coal emissions. And I don't think that comes as a surprise to folks who follow that market. But it's not just that small incremental change over 1 year. If we look back into the data, we see that 7 out of the last 10 years, we've seen a decrease in CO2 emissions in the energy markets. And if we look back to 2015, we see that CO2 emissions in the energy market are down 14%. Now, overall energy use that I mentioned earlier, that's part of the explanation. Overall energy use is down about 2% from that period, 2005 to 2017. What's happened to the economy? Well, economy's been up and down. On average, or in total, I should say, since that period, 2005 to 2017, the economy's grown 20% in real terms. So the economy is 20% larger. The amount of CO2 in the energy market is down 14%. This means that the amount of CO2 per dollar of output is down, and it means the amount of CO2 per million BTUs is down significantly as well. This is in part innovation at play, right? This is the markets adapting to changes in technologies and changes from what I might call non-price signals, people's preferences for different types of energies. Now, the question you might ask is, well, maybe we're headed on the right course without a carbon tax. I think there are limits in the current pricing framework to that amount of innovation that we're going to see from this sector, and that a carbon tax on top of this innovative capacity in this industry will both accelerate the timing of future innovations and ultimately lead to a higher level of innovation and newer technologies, again, both in terms of clean energy, but also in terms of conservation. Some of these products are not necessarily innovative, I think also should be recognized. One can save energy by putting the pink stuff in their attic, right? By putting down insulation in their homes and things like that. Those aren't necessarily the same kind of innovative technologies that we might associate with a new type of solar panel. But all these products, the returns on those investments go up when the price of electricity or home heating goes up, and that thereby inducing more demand for those products. And finally, the third point I want to make, and this is also one that Joe mentioned at the end of his remarks, is these policies should not be considered in isolation. A carbon tax is going to raise, depending on the price that it's set, in the order of magnitude of $1 trillion over the next decade. Something must be done with that money. It's not a choice. Something must be done. Absent, explicit policy, the deficits will be reduced by that amount. But of course, those monies could be used to expand the earned income tax credit or the child tax credit. It could be used to lower the corporate tax rate. The issues that Joe highlighted could be used to create, in essence, my view, a sort of a new entitlement program, and those monies could be sent back out to households or to taxpayers. But something must be done, and there will be consequences, economic consequences of that choice as well. So Joe has suggested that we think carefully about investing those monies or some of those monies back into R&D to further promote the innovation. Certainly one of the options on the table. But I think when evaluating a carbon tax and the merits of a carbon tax, we should be thinking both about the energy market effects, the climate effects, and also the consequences of the use of the revenues. And thank you very much.
Thank you, Alex. Next speaker is Joe Maka, Director of Climate Policy at the Niskanen Center.
Push the button. Yeah, thank you for having us. This is I love talking about carbon taxes and thinking about them. It's an issue where the sort of top line simplicity can quickly fall apart when you think about how big of a policy step embracing a carbon tax would really be. Excuse me. And then you can get into some really interesting things about what do you do with the money? How does this offset other policies? How can this lead to reforms that create the future that we all want? And I wanted to touch on that. Alex started, but I think it's important to think about, a carbon tax is a mechanism for internalizing the cost of carbon and sort of creating a high-level, economy-wide, fair, ambitious program to deal with climate change. And for the U.S., that means creating a world where we can have an equal or greater quality of life by 2050 with almost no carbon emissions. That is a necessary but insufficient condition to keep global warming above 2 degrees C, which is sort of an internationally recognized barrier beyond which we start really probing dangerous risks from upsetting the climate system. And it's a really interesting set of numbers that, if you allow me the indulgence to go into for a second. Alex started, we've seen this, 14% reduction over the last 10 years as, technological innovation brought gas to be very cost competitive with coal. And other regulatory schemes have made coal more expensive, and you've seen this kind of shifting behavior. But the extent to which we need innovation in our energy system to accomplish this goal of nearly eliminating greenhouse gas emissions from the U.S. economy, right? Fundamentally changing the metabolism of the economy in the next 30-odd years is really staggering, but also exciting. There's some really interesting work that's been done on this. But basically, to accomplish that goal, right, removing carbon emissions from the American economy, we need to more than double the rate at which GDP per CO2 is accomplished. And we will look. It's important. It's good to think about a little bit what the world looks like when you do that, right? Because you can think about innovation from one context, and it's you have this Tony Stark character in a garage breaking the laws of physics and making a new kind of non-emitting nuclear process. Or you have what the innovative process will really look like, right? Which is a bunch of management consultants talking to an industrial emitter about what kind of scrubbing equipment or what kind of boiler they should buy. And I think that the innovation process is going to lead to a significant climate action in the U.S. and would be spurred by a carbon tax is going to be much more the latter than the former, unless we get incredibly lucky. And the world will be very, very different. So last night I was looking coincidentally, but thankfully, at this report that was produced a few years ago by the Lawrence Berkeley Lab and the Pacific Northwest National Lab. And they looked at kind of different scenarios for what's called deep carbonization, right? Achieving an 80% reduction in U.S. greenhouse gas emissions by 2050. I wanted to run through a couple data points just so we can kind of ground the sort of the innovation that we want to have in the long term. They found that it is totally technically feasible to reduce greenhouse gas emissions at that level, right? So we don't need this like Tony Stark scenario, but it's going to be really different. So in most of their scenarios, you have roughly double electricity production that you have today, but we're producing electricity at less than 10% of the greenhouse gas intensity that we do today. It's a massive set of investments in technology that exists, but like processes that we don't quite know yet how to finance, how to fund, how to carry out. Cars probably driving about the same amount of miles, but you want 90% of miles to not be fueled by emissive gasoline, right? So that means we've got alternative vehicles, either burning hydrogen or biofuels or electric cars, and those electric cars need to run on clean electricity, right? Because you don't want these just substitutions occurring. And when you think about it in that context, you start thinking about, okay, well, how many infrastructure cycles of some of this stuff do we have before this goal of this goal time of 2050? And it's actually really truly remarkable. So they looked at lighting equipment, right? So the efficiency with which we use energy. You've got about 4 generations of LED light bulbs or other lighting technology before 2050. You've got 3 generations of residential hot water heaters. 2 generations of light-duty vehicles, so that's a family car, as well as furnaces, so things we use to heat interior spaces. You've got 1 generation of heavy-duty vehicles, 1 for trucks, 1 for industrial boilers, and 1 generation of power plants that will come online between now and when we want this sort of tiny remainder of emissions to be in our world, and 0 for residential buildings. So basically a building that's built today is going to have people living in it. So like fantasies about having a drastically different urban planning structure are just not going to be workable. And that I think is important to think about in this context because a carbon tax, as compared to the other policy mechanisms that can be used to drive that scale of innovation, has unique properties that I think make it most likely to help us achieve them, right? So you've got all these different sectors, all trying to reduce their greenhouse gas emissions, all trying to make a business case for doing so because we have a market economy. It's created a ton of wealth. It's really dynamic. It allows technologies to diffuse relatively rapidly. And we want to align the motive of that market economy, which is profit, with social welfare. So a carbon tax allows every actor in that economy to understand and to include in their decision-making, in their fiduciary duty, the idea that, oh, well, reducing greenhouse gas emissions is going to make us more competitive against the other people who provide the same services that we do. And it does that better than other policy instruments. For instance, environmental regulations, right? So you could think, oh, well, we can use regulations to do this, except that regulations are bounded by these sort of cost-benefit analysis that have to occur. And there's a huge information asymmetry. So the EPA or some other regulatory agency can only say, here's what we think is the set of standards for a coal plant that is fair, reflects the costs of this type of pollution, but doesn't overly burden people who own coal plants, right? That's a really clunky system. You can make an upgrade, then you're good for the next 10 or 15 years. A carbon tax, however, every innovation that you bring online to reduce your greenhouse gas emissions still pays back. So if you cut your emissions in half, right? I change from coal to gas. I can still, by reducing emissions, improve my prices compared to my competitors. And a carbon tax is particularly special because everybody who's doing emissive processes has that motivation built in basically from the moment that the tax exists, certainly within the first year. So when you look at this big innovation problem, this goal of reducing greenhouse gas emissions 80%, it's hard to fathom another program being able to diffuse technology that quickly than something like a pricing system. And then the induced innovation that occurs just lowers the cost or conversely makes the program more effective. Those are the 2 things I wanted to mention. Happy to entertain questions later. Thanks for having me.
Thank you, Joe. And our third panelist today is Donald Marron, Institute Fellow at the Urban Institute.
So hi, everybody. Thanks for having me. Glad to be part of this conversation. I'm one of many people here who's part of the secret carbon tax cabal, plotting for the day when this becomes politically viable. Just wanted to make a couple of points. So the first is, let me put out, among the many things I've been in my past as an economics professor, and the one thing I always wanted my micro students to take away is if you remember nothing else, remember that people respond to incentives. It's just, a universal truth that turns out to hold in all sorts of settings, particularly holds in the marketplace, where prices are one of the most important incentives that people and businesses face in their daily life. And then obviously a carbon tax can change prices, and then as Joe illustrated with his orange and blue lines, right, can change incentives, and that's really powerful. And then I was going to do a very long song and dance, much like the one we just heard, about why that's so powerful, but I'll do the short version of that. Which is, if you do a substantial, so a large and broad carbon tax, so you're getting lots of the economy, right, it filters through and affects the incentives of people, businesses, governments, all economic actors out there to think about ways to use less carbon, right, even without knowing that that's what they're doing. And it filters through to all sorts of life decisions about where you live and how you heat your home, and do you switch over to an electric autonomous scooter to go to work? I don't know about the autonomous part. All those things, just all these consumption decisions, all these investment decisions. The beauty, again, if it's broad and if it's substantial, is that it can affect gazillions, technical word, of decisions that people in businesses and governments make without any centralized authority having to be aware that that's an important decision. It lets small decisions be influenced, but big decisions be influenced, and it lets them be influenced both in an immediate, how should I run my life today and tomorrow, how should I run my business today and tomorrow sense, and as Joe emphasized, in a planning for the future, how should I innovate in my business or in my personal life in order that the burden from a tax, the burden of the prices I face will be lower in the future, right? So in principle, a carbon tax can be a very effective, powerful tool for kind of moving all sorts of decisions throughout the economy. But again, I want you to think of, we in the carbon tax cabal often talk about a carbon tax, but I want just to emphasize, right, that there are a bunch of parameters that define what a carbon tax is. Not all carbon taxes are created equal. So obviously the breadth of it matters, right? How much of the emissions are you capturing? Do you stop just at energy-related CO2? Do you get all of energy-related CO2? Are there some exemptions? And then do you get other sources of greenhouse gases that matter as well? So all else equal, broader is better if you can make it administratively possible. There's an issue about size. Right, so obviously bigger is better if your goal is to induce change and induce innovation. And then there's also an issue about trajectory, right? What does it look like into the future? Particularly when you think about long-term investment decisions and long-term innovative decisions, it's not just the carbon tax today that matters, but it's what people expect it to be in the future and how they bring that forward into their decisions today. And then that gets into very sensitive issues about not just what the path of prices that your bosses write down in legislation is, but really what people expect, right? What's politically viable? What's a plausible trajectory? What are the major corporations and the small corporations in the world going to put in their spreadsheet? And kind of the higher and faster that rises of what goes in the spreadsheet, the more innovation you're going to get and the more change you're going to get. Second point, and it's again something that Joe alluded to. A carbon tax is in many ways a substitute for other policy levers you could pull on. Right, so you could think about various regulatory policies, you could think about various subsidies for adoption of clean energy, you could think about various subsidies for pursuing clean R&D. And those, to the extent they're attacking the same problem, you can think of those as substitutes. And if you succeed in getting a broad, large, robust, rapidly growing carbon tax, the need for those other policies goes down, at least in an analytic, right, orange and blue lines kind of exercise. But again, I want to emphasize that really depends on the parameters. We often talk about carbon tax and regulation as being substitutes, and they are in some sense, but if you're not politically able to get the carbon tax big enough to accomplish all the environmental things you need, then the reality is you're going to need to live in a mixed world where you're doing some of the work through a carbon tax and some of it through other levers that you might pull on. And then in addition, it's also true that you may have other goals that you're trying to aspire to, right? Again, Joe mentioned that there's this issue of co-benefits, right? So it turns out that particulates are really bad for you. And that even while we've made a lot of progress over the decades, we still have some particulates that are really bad for you. It turns out carbon tax by itself would reduce emissions of particulate matter, and that would be good for you. But if you're solving or addressing the carbon problem over here, that doesn't mean you should, even if you make substantial advances on the carbon tax side, that doesn't mean you should ignore that. And so you may want to have policies that go after those other environmental issues. And then as Joe said also, there's this longstanding, and Alex said, there's this longstanding concern that innovators don't capture all the benefits of their innovation, and that you may want to think about policies to subsidize that and encourage that. And that continues to be true even in a world if you manage to get a truly optimal and large enough carbon tax. So you still may want to use other levers, but you should also just keep in mind that carbon tax, both analytically and practically, but also politically, provides some room that if you're doing it on a robust level, you may be able to roll back some things. So then brings to what at least my piece of the carbon tax cabal ends up spending enormous amounts of time on. I feel like there's actually a pretty good sense about the design of the tax side, right? So you want it to be relatively upstream, so you're not taxing that many places, and it's administrative feasible, and you want to make it broad. And so a lot of the conversation really is what you do with the money. And ultimately, that's political sausage making, but I think it's useful to have a framework for thinking about that. And one way of divvying it up is to think about that first, there's a set of people and organizations or groups that are going to be hurt by a carbon tax, and that you may want to use some of the revenue to help them out, right? And so coal miners and coal communities turn out to be one category for that. It turns out that the amount of money at stake in a substantial carbon tax is so big relative to that that really doesn't move the dial very much in terms of the dollars, so you can do that. There's an issue about the fact that consumers will face higher energy prices and will feel it in their pocketbook. And so that you are probably going to want to devote some revenue to that. And then that discussion branches into do you focus that on low or low moderate income folks through some sort of tax credit, or do you go in sort of the more dividend approach where you take the vast majority of the revenue and recycle it to folks as a way you can't hold everybody harmless, but to hold more people harmless. But then there's this political thing, right? So if you ever do polls on this, I think Joe mentioned this, right? The polls always say that people want to use some of the money for clean energy R&D or clean adoption. If you believe my substitute story, that doesn't actually make sense when you put your narrow economic blinders on, because the reality is if we weren't able to do a carbon tax, I would be telling you we should do even more R&D and subsidies for adoption. So I as economists view them as substitutes. But politically, you see a lot in the polling that people think that you ought to, if you're doing something green with the tax, that you ought to do something green with the revenue. So you're probably going to want to check the box with some revenue going towards that. And then you have this issue about, well, carbon tax, at least in conventional models, shows a reduction in GDP as conventionally measured relative to baseline. And so there's a question about whether you want to use some money to try to do pro-economic growth things. There used to be a whole literature that I contributed to about using some of the money for reducing taxes on capital and corporations. The corporate tax rate seems to have fallen precipitously in the meanwhile, so I'm not sure there's as much life in that literature. There were those of us in the cabal who used to think that, if corporate tax reform is going to require $1 trillion or $1.5 trillion money to be revenue neutral, of course Congress will adopt a carbon tax because it fits in there really nicely. But that turns out not to be the path we followed. But there are other things you could do to be pro-growth, right? There are various investments you could make. You could try to encourage more innovation. So that's a discussion you should have. I would say, I think an important contribution of folks who focused on the dividend strategy is to frame the discussion significantly in a political dimension and to ask what use of the revenue helps get a substantial, robust carbon tax enacted. And interestingly, they also pose the question of what will enable the carbon tax, the robust rising carbon tax, to continue existing. Right, because we do have experience in some other countries where you cross the goal line, you get a significant carbon policy in place, and then a few years later it goes away. And so an interesting thing to think about is, are there revenue uses that reinforce that? Right, and so you will hear advocates of the dividend view saying that dividends reinforce it because every year people see the dividends coming in, and that gives them warm fuzzies about the carbon tax and will help maintain it. And you should ask similar things about other potential revenue uses. And with that, look forward to the conversation.
Thank you, Don. Great. So I have a lot of things to say, but I'm not going to say them. And this is a chance to have some comments and questions from the audience. We're recording this for future broadcasts, so I'm going to repeat the questions. Hopefully, I won't do any violence to your meaning when I do that. And if you could identify yourself briefly for the people in the room, please do so. And with that, we're going to open it up. Yeah, in the front here.
I just wondered if, in terms of the drivers here, the demand for environmental action, the drivers for carbon tax, versus the need for revenue in this post-2020 period, whether it's deficit reduction or Social Security, there's a lot of needs that are out there, whether it's revenue, the assumption that there's going to be this sort of congressional search and rescue effort to find money. What do you think the driver in the end is going to be, the demand for that revenue or the need to act on climate change?
So the question is about the demand for this policy, how much driven by environment and how much driven by revenue. I don't know who wants to take that. Joe,
So-
yeah, why don't you start?
Yeah, I think, I mean, obviously, both needs exist. We want to do something on climate change, and I believe that we're going to have to do something on deficit reduction, and whatever we do is going to have to require new revenues. I suspect that it would be wiser to keep the two issues apart, and that to build support for doing something on carbon emissions. You're going to have to, the deal is going to involve using the revenues for something other than deficit reduction, because I just suspect that there's not going to be enough support just to have additional taxes that are that you use to reduce the deficit. I think the impetus for doing something on the deficit is going to be, it's going to come. I'm not sure when it's going to come, but the financial markets will put pressure on Congress to do something, and at that point, and not much sooner, Congress is going to deal with the issue. And so I don't, you know, I'd hate to see us wait to do something on carbon until we have a financial crisis and need to raise revenue. And I'd also hate to see us not do something on carbon because we're unwilling to use the revenues to build more public support for the tax.
Just a brief pile on, and I think probably Alex has a lot to say on this regard as well. I think, you know, the carbon tax and the associated environmental benefits are a big reason why we talk about them a lot. Generally, when folks introduce them, the headline reason to support a carbon tax is environmental benefits. We've seen other examples. Carlos Corbello introduced a bill this year that tries to use carbon revenue for infrastructure spending. Whether we have an environmental push or a deficit pull, I think is unknown, right? Like that's a question for the fates. But I think if you're solely focused on financing, there's lots of stuff to tax. And so the reason why we tax carbon is environment. And if you're talking about like a vote-getting situation, understanding the environmental impact or the environmental desire or the desire to act on climate is really important.
I suppose it's also worth mentioning the magnitudes here. We're going to run a deficit of about $1 trillion. Is that right, Don? And this would bring in about $100 billion a year. So it would be a small piece of the pie as we're looking at it now. Other questions? Yeah, here.
Thanks. I'm Alex Moses, and also a former AAAS Science and Technology Policy Fellow. Could you say more about the disincentives of capital infrastructure made obsolete by innovation? This was a barrier when I tried to commercialize a high-performance, affordable cement with 97% lower CO2 energy.
So we might translate that into stranded assets, that is disincentives for,
I'm not an economist, but
okay.
go ahead and do it.
Okay, well, maybe I'll ask somebody else if I got that one right.
Take it again. So I think one of the problems in the energy sector in general is that you have these huge investments that last for a long period of time. So if you switch the rules suddenly, you can have people who built a power plant that's supposed to last 40 years, and they built it 10 years ago, and now you're telling them build another one, and that does impose a huge cost on society. I'm not sure what the best, I think it's important to form an opinion about how fast you think technology is going to develop if we raise taxes. If you think it's going to develop faster than most models predict, then you would want to reduce the tax in the near term, allow the innovation to occur, and then after 10 or 20 years, buy a lot of that cheaper innovation. And so not force people to do much, that costs them a lot or strands assets in the next 10 or 20 years, but wait for the technology to really accelerate and then buy in. But that's a bet that technology is going to advance pretty quickly. If you don't think it is going to advance quickly, or you think that the big problem is we have the technology now, nobody's using it, then you would want a bigger tax right now to force everybody to buy in. And that most people think that the more people who adopt a technology, the lower the cost of the technology. So you really have to sort of decide how much you want to bet on the pace of technology.
I just add, there's one way to think about that question in political terms, and I think that political terms it's a big drag. Because if you have a meeting of the stakeholders, it's hard to invite the guy who's going to invent the thing that hasn't been invented yet, because he doesn't know to go to the meeting. But it's easy to invite the guy who just made the investment that's going to be lost. And so that's a big political problem. I think from a sort of welfare analysis perspective, the economist doesn't care. I think you just, to the extent that there's an asset out there that's harming the environment, and the potential for new assets in the future that are less harmful, you want to bring that tax on as soon as possible.
And I think this point about being a constituency for the future is crucial, and that's where public officials need to come in. And so those of you who work up here, we're counting on you to speak on behalf of those innovators who don't know yet that they need that tax. Yeah.
Hi, my name is Alexander Fitzhugh. I'm an economics student from Southern Oregon University. I'm on vacation here.
That's really nerdy way to spend your vacation.
So carbon is a global issue. What of the problem of the outsourcing of carbon into other areas of the world that are less well regulated? How would you account for, like, if it's a power plant or something, you're not going to offshore that. But for a lot of production, how do you account for that global reduction of carbon output? Would you need something like carbon tariffs or something? Or how would you even measure the carbon output of somewhere from India or some rural China or something like that?
So this is a question about the global nature of the problem versus the national application of the tax, and it had a recent birth as the border adjustment tax, I believe is how it was referred to in the recent discussion.
So just a couple of things. So exactly you say, right? So one approach that people have suggested and are working out the details for is some sort of carbon border adjustment, which is relatively straightforward for things that are like have a very high energy content that you can easily measure, but rapidly gets very complicated as you get into more complicated goods, and particularly given the complexities of global supply chains. And so it's one of those trade-offs that obviously it's not going to be exactly right, and then you can have a debate about is it close enough, does it work, and also does it give incentives for other countries to raise their game. And then, and then obviously the other strategy is, grand multilateral negotiated deals with our allies and friends and partners and competitors around the world. That has fallen a little out of favor in the current political environment. But in principle, that could get one down, beginning to take steps down that road of encouraging people to go. But again, you have this issue about what the incentives are. And if you could make a border carbon adjustment work, that would provide pretty good incentives for certain countries that, export a lot to us. But it's not going to be enough, right? Because there's a whole other world of, what about the place with low environmental standards that trades with the place with low environmental standards, right? There's that thing that you really need, the more multilateral stuff to address.
This is actually a question, a follow-up. How do we think about induced innovation in terms of carbon leakage or the international nature of this problem, right? So part of the climate problem is you want to see, or we expect to see, rapid economic growth in Southeast Asia, Sub-Saharan Africa, and you want that development to be relatively carbon neutral compared to how we developed. Is there a case for innovations that occur in the United States or in other developed countries being exported? And does induced innovation reduce the cost of kind of global climate action in the same way we expect it to do here?
I'll just briefly comment on, the beauty of innovation and knowledge production is that it's a global public good. In that sense, it's a bit of a mirror image of the global public bad of climate. So whatever induced innovation is caused by the carbon tax, there is some spillover to the rest of the world. Exactly who gets the benefit? We've seen situations where the U.S. has created the innovations, but other countries have capitalized it. So, it's a complicated question. There should be some burden sharing as well. I think this is part of the challenge. But I think there is a spillover to the rest of the world from this induced innovation.
Can I just jump in with one additional point on the border adjustment? I think the border adjustment aspect is really interesting, especially to tax geeks. But I think the importance of having a border adjustment to the carbon tax is a function of the rate of the carbon tax itself. So we have lots of policies in the United States that we impose upon ourselves to disadvantage ourselves relative to other countries. We have a minimum wage and things like that, raise costs of production here. We don't border adjust our minimum wage. We don't try to do that. If you had as Donald described, a large and robust, carbon tax, it's a significant rate. I think you need to really take serious the question of this border adjustment issue, which would be a tariff, as you suggested in your question, and also an exemption of that tax on exports. So it's two sides to that policy. But if you were to start with a more modest carbon tax, it's not obvious to me that you would necessarily want the complications that come from a border adjustment policy. It's just I don't know that for sure, but I think that we need to sort of evaluate the pros and cons of a border adjustment in the context of an understanding of what the overall tax rate is.
So the question here is about the equity impact of the carbon tax and whether it's necessary given the rate of decline in carbon emissions.
I'll offer a partial response. I don't think there's much doubt that carbon tax is regressive. The total burden on lower income people is less than the total burden on upper income people, but as a proportion of their income, it is, the proportion is higher at the low end. We have a lot of sales taxes and other taxes that are regressive too. This would, I'm not, depending upon the tax rate, it would compare favorably or disfavorably to them. But the real purpose of having doing something on the energy side, I think, is to deal with climate change, which many people still deny. But if you believe it's real, then, the pressure goes up to do something about it. And I believe, it also depends upon whether you believe we're sort of maybe at a cusp of significant energy breakthroughs if we spend some serious money trying to encourage them. And if you believe that the energy markets are, about to undergo substantial change, and you use the revenues to reduce growth, which many conservatives like, they like the idea of growth more than they like the idea of redistribution, then there is a real possibility for a win-win-win situation. And yes, the tax is going to fall on somebody, but I think people at the lower end are going to also benefit by higher growth. At least I kept hearing that during the debates on the tax bill, where people didn't give low-income people a lot of tax breaks, but they said, well, you'll get it in the form of higher growth. And so to some extent, that's true.
So I think this is super important. And, it goes back to what do you do with the revenue, right? So there are certainly, at the analytic level, right, there are plenty of scenarios where the money that goes back to low and moderate income is enough that on average they come out ahead, right? So the carbon dividend proposals have that feature. Some of the tax credit proposals have that feature. Obviously, there's always going to be, some folks who are left behind, but you can easily have, the vast majority of low and moderate income folks come out ahead if you're willing to use all the money for that. There's a question about whether the politics will get there for you. And then you raised an important issue about, there's an issue about when the money comes in versus when they're feeling the burden. And so traditionally, there's been in this discussion a focus on the tax credit approach, where when you file in February, March, April, you could get a tax credit that has been expanded because of the carbon tax revenues. And that creates exactly the problem you're describing, is that you're getting the money back in February, March, April, but you were bearing the tax the whole previous year, and that's really problematic for folks who don't have very much liquidity. And so one reason for the dividend approach has been to try to align that better, right? So then rather than asking the IRS to do it through a conventional tax refund, you could set up a mechanism to send people checks. And then, there's a discussion about how frequent they would be. I've looked at this, and my sense is that quarterly is probably the sweet spot in terms of frequency versus the administrative burden of doing it. But, if it got big enough, you could make a case for monthly. And then there have also been some experiments in having the IRS have the capability to do things monthly for other kinds of credits, which is an area of a lot of research around the earned income tax credit and other things. So I think that's really important because, right, ultimately what you would want is something that is pretty much in real time holding harmless folks with low incomes from bearing a severe burden from this. And thinking about design that does that, I think, will be important.
I also just wanted to address the other part of the question, which is the very high energy use in the U.S. And so we have a high baseline that we're starting from when we look at those declines. So there's a lot of cheap energy savings that we can do here, which other countries have already done. So we just have to bear that in mind when we look at the comparative context. Yeah?
Lee Ketchum with the UN Foundation. Donald, isn't another approach to
So the question is whether you could send the check before the tax is imposed.
You could send it, before, you could send it contemporaneously. For those of you, any budget geeks in here, so you start running into pay-go issues about the timing of when the money comes in and when the money goes out and making that work over a 5-year window if you're doing this under pay-go constraints. So that affects the math a little bit, but you could certainly, right, try to design it that way. And in particular, I should just note, in particular, there are issues around when you start the program, like year one. So there's an issue about how much of a time lag you give between enacting the law and when the tax goes into effect and when the payments go out. And when you guys are writing this law for us, you should be thinking about that it's hard to stand up some ways of getting the money to people quickly, and so they're going to need some time. But sure, in principle, you could front load it a little bit as a way to even soften it further.
Can I just add, one, we're pretty deep down in the weeds of this carbon tax design, which is fun, I guess. But I wanted to say, one is if you were to use the tax to reduce the payroll tax, You don't need the new bureaucracy associated with a check issuing mechanism. Now, you don't reach all the same people, but a lot of people pay payroll tax. And so one of the ideas that's been floated is to use the revenue as a payroll tax reduction, and that would grow paychecks immediately and allow people the ability to pay their higher energy costs. Second, it's actually a complicated question with respect to who the impact on poor people, because poor people aren't all the same. Someone who lives in San Diego and takes the bus, to work, uses far less carbon than someone who, lives in Maine and drives 50 miles to work. And so we should be careful not to kind of just think of all poor people as using the same amount of energy. There's really tremendous variation, both by income but also within income.
Yeah, I think this goes back to the point I was trying to make earlier. We're doing something audacious here, right? Trying to shift the metabolism of the economy is not a small thing. And people are going to get disturbed. Industries are going to get disturbed. Certain individuals are going to get disturbed. And so careful policy design should be totally a part of that. And that's why we have the democratic process, right? People can reach out to the legislators and say, I don't like it or I want it. But I think the general idea that any one particular group of people gets in the way or has a veto over this general interest policy is mistaken, because what we're really trying to do over the time scale of my children, our grandchildren, is improve the net welfare of the globe, everybody on it. And we want to make sure we don't adversely or unfairly harm particularly vulnerable people along the way. That's a matter of policy design. It's really not a veto.
Question on this. I agree with the central principle here that increasing the tax, having a carbon tax will will induce innovation. But my question is, if you look at Europe, for example, they've had decades of high tax on this carbon-related thing, either in the form of social cost of carbon or cap and trade. But I haven't seen a great many, innovations coming from it. To the contrary, all this great innovation is within the U.S. For example, this NGCC, which is a power plant with the combined cycle, spurred by hydraulic fracturing, cheap gas from hydraulic fracturing. So that's my concern here.
So the question is about the effect of carbon taxes or their equivalent in other places in the past, particularly in Europe, and what has been the innovative effect of that?
So I tried to summarize that in the presentation. There's in particular there's a study by Calel, C-A-L-E-L, from earlier this year that looks specifically at the EU's cap and trade program, and that discusses the fact that previous cap and trade programs have not induced a lot of innovation, but does argue that at least in the EU case, and at least for United Kingdom companies, there has been a significant movement toward faster innovation in cleaner energies. And so in some of the other studies that look at specifically a carbon tax, almost unanimously conclude that there will be significant innovation. And if you go back and you look at the experience of the 80s when companies faced higher oil prices all of a sudden, they did shift their technology and they did invest a lot more and patent a lot more in cleaner energy.
I think it might be worth here as well distinguishing between incremental and breakthrough innovation. And we talked about the two market failures. In Europe, of course, they do have different cars, different buildings. All of that is partly affected by their tax structure. But what they haven't had is some of the more breakthrough innovations, and that's in part because they haven't had Department of Defense spending, other kinds of push policies that we have in the United States. So I think we'll take one more. Yep, here.
Hi, Lindsay Walter from Third Way. I really appreciate the conversation on mitigating the energy cost burden for low-income households, but I wanted to take a step back more towards that innovation focus, and there's been a lot of discussion on capturing the gains and rewards of R&D, and as David was just touching on, there are different types of research, and I'm wondering how in the structuring of a carbon tax you would see the role of funding research that's early stage, more high risk, versus the translational research to actually get to see the work of your research come to fruition and be commercialized and put into the market, and how you would ensure that the design of revenue from your carbon tax would be more strategically oriented to seeing the creation of the technologies you see as necessary to ultimately reduce emissions at the rate that we need.
So I can't do justice to the question, but I will just try to summarize it by saying how can we best use these revenues to accelerate innovation? So beyond the induced effect, but also using the revenues. Joe, do you want to talk to that?
I think given the characteristics of the energy market, where you have to make long-term bets on an existing technology, and also given the view I have that this technology can advance quickly if we spend a lot of money on it, you would want to encourage basic research early on, and you'd want to do that through direct government programs like DARPA, EARPA, but also to underwrite private research in more basic technologies, and that hope with the hope that in 10 or 20 years you make significant advancements, and so at that point you incur large investments that lock in the use of that technology. So my personal inclination would be to bet big on basic technology.
So we have a few minutes left, and I don't know if any of the panelists would like to make some concluding remarks. Otherwise, we will yield the balance of our time to the audience to use this slide. Like, Joe, do you have any?
Yeah, I just think for me this issue is one of, the evidence is building. It's not conclusive on many fronts. It certainly isn't conclusive that we should have taxes that are high enough to hold us to 2% or 2 degrees Celsius. That probably is too high a tax. But the evidence, I think, is growing that some action should be taken, and that moderate action can actually, if we use the revenues well, can achieve significant reductions at low or no cost. And I think this is the energy, the technology of the future, and we ought to choose to buy into it and to establish ourselves as the leader in the technology rather than following other countries.
I think that's a great place to end. I want to thank our panelists for their remarks. Thank you guys for your great questions, and make sure that everybody knows that we have a stack of the reports outside. So please grab one when you leave. And thank you again for coming.